All right, jumping into a new chapter here. We're going to deal with roots and radical expressions. So in this chapter, we're going to talk about adding radicals, multiplying radicals, simplifying radicals, all things that we've done before, but we're going to kind of advance those into, we basically only dealt with square roots. Now we're going to deal with cube roots, fourth roots, fifth roots, so on and so forth. So 6.1, again, very definition based. The math is fairly simple once you understand roots and radicals. So we're dealing with again, you can read this here, corresponding to every power, there is a root. So just like you have 5 squared equals 25, when we go the inverse of that, we could say that 5 is a square root of 25. 5 cubed equals 125. So 5 is a cube root of 125. When we're taking the root of something, we're getting a smaller number. So it's important for us to know perfect squares, perfect cube, perfect fourth roots, and so on when it comes to these numbers. So we're going to talk about that a lot in this chapter. So this is very important here where we have our radical symbol, okay? So this number up here, we're so used to everything being just a square root up until this point. So if I had this is the square root of 64. There's no number here. There is a number here. We just don't show it because it's the most commonly used root. So we call this a square root. Well, now we're going to be given a number in this little area. If you don't see one, then it's a square root. So that's called the index, okay? And then the number underneath is called the radicand. And we have the radical symbol is the other part of this where I'm going to make sure that we understand those different parts of a root. So when I have a problem that looks like this, is if a to the n power equals b, with a and b real numbers and n a positive integer, then a is an nth root of b if n is odd. So I'm saying if the index is odd, there is one real root. Okay, that root is either positive or that root is negative. If n is even, so I have a square root, a fourth root, a sixth root, and b is positive, okay, so that would mean the number under here is positive, then we have a plus or minus root. Okay, if b is negative, or this value under here is negative, then there is no real nth root. And that's what we had when we had in chapter 4, a negative underneath the radical. We said no real solution. So we're going to look at a few problems here and just understand it's really, again, I'm asking you what number could I multiply this to equal when it talk about a cube root or a fourth root. So for this first one, find all real roots. So first of all, I'm dealing with cube roots, which means the index here is odd. So for part A here, the index is odd, which means that I'm going to have one real root. It's either positive or negative, okay? And these are going to be all perfect cubes here. So I have 0.08. So if I wanted to write 0.08 or 0.008 as a fraction, that would be 8 over 1,000. Okay. Well, this right here is an odd root. And what number cubed equals 8? That would be 2. And what number cubed equals 1,000? And that would be 10. So this would simplify to a 1 over 5. And it's positive because this is positive. What number cubed equals negative 1,000? And that would be negative 10. So for the second example here, the answer is negative 10. That's because negative 10 times negative 10 times negative 10 equals negative 1,000. Cube root, again, I'm looking for 3 of them, but it's just negative 10. You get one answer. For 1 over 27, okay, that would be 1 times 1 times 1 over 3 times 3 times 3, which is 1 over 3, and because it's positive, the answer is positive. I'm allowed to have a negative odd index root. When it comes to part B here, what are the fourth roots? Okay, so the fourth roots of 1. So I'm asking what number can I multiply by itself 4 times so that it equals 1? Okay, and hopefully the answer to that is, as you know, 1 times 1 times 1. Okay, but here's what happens when we have fourth roots. What if I multiply negative 1 times negative 1 times negative 1? Doesn't that still equal 1? So for this first part of this answer, the answer is plus or minus 1. Okay, for this negative 0.0001, I can't have an even index and a negative answer. So this would be no real roots. And then for this 16 over 81, again, what number times itself 4 times equals 16? It'd be 2. And then what number times itself 4 times equals 81? And that would be 3. So this answer would be plus or minus 2 over 3. And again, the answer is plus or minus because I could multiply negative 2 over 3 times negative 2 over 3 times negative 2 over 3 times negative 2 over 3, and it would still give me a positive 16 over 81. Okay, so what is each real number root? So again, look at the index. If the index is odd, then I can have a negative answer. So this would be, what number can I multiply by itself 3 times to equal negative 8? That would be a negative 2. Okay, odd index, I can have a negative answer here. Right here, negative 0.04, which is 4 over 100. This is a square root, right? So what's the square root of 4? 2. What's the square root of 100? 10. Okay, so that's 4 100ths. So if I simplify that, it would be 1 over 5. If I take the square root of that, okay, and again, you can just use your calculator, square root of, but again, I'm asking you what the answer is, and it's plus or minus here because the index is even. Anytime the index is even, my answer is plus or minus when I'm talking about the real roots. For part C, I can't have a negative underneath here, so no real roots. And for this one, I can take the square root because negative 2 times negative 2 is 4. What is the square root of negative or of positive 4? It's plus or minus 2. So when I'm talking about just roots, I'm talking again about the positive or minus when the index is even. If the index is odd, I get just one answer. Okay, so again, you'll see some answers here where I tell you that the answer has to be in the absolute value because it has to be positive because we can't have a negative underneath the radical. And that deals with when we're dealing with exponents. Okay, when we're dealing with exponents, we don't know what that number is yet, but I can guarantee that it's positive by putting it underneath the absolute value sign. So what is a more simple form of a radical expression? Well, this is a square root, which means I have an index of 2. Okay, if it's an even index, if n is even, so I have an even index, when I simplify it, my answer has to be in underneath a square root, or I'm underneath the absolute value. Okay, so when I simplify this right here, what's the square root of 16? It's 4. What's the square root of x to the 4th? And again, I'm looking for pairs. The reason the square root of 16 is 4 is because it's 4 times 4. Well, what about x to the 8th? Doesn't this mean 8 x's? I'm looking for groups of 2. How many groups of 2 can I make? 1, 2, 3, 4. So this would be x to the 4th. And that's in the absolute value because everything has to be positive because it's an even index. Here, I have a cube root, which means I'm looking for groups of 3. So I have A, groups of 3. How many groups of 3 can I make? 2. So this would be A squared. How many groups of 3 can I make from 9? And that would be B to the 3rd. A simpler way to do this is just divide the exponent by the index. Same thing here, but because it's an even index, my answer is going to be in the square root. So I've got x squared, absolute value of x squared, y to the 3rd. And again, when I do this, I don't really need to put the positive exponents in the absolute value because they're always going to be positive. But the odd exponents, I have to, because if it's negative, it will end up being a negative value. And I'm not allowed to have a negative under here. So you might also see it written like this, x squared y to the 3rd power. If the exponent is odd, then it has to go in the absolute value. Okay. So that's 6.1. You're going to have some problems to deal with this. Again, it's just dealing with the roots and radicals. And then we're going to get into 6.2 the next day, which is going to be a little bit more of simplifying, a little bit more things that we can do mathematically related.